The graph of y equals g of x is a straight line. The domain of g of x is 2 is less than or equal to x is less than or equal to 8. The range of g of x is 5 is less than or equal to g of x is less than or equal to 23. Work out one possible expression for g of x.
The domain, the input of a function g of x, is the set of all values for which the function is defined. The range, the output of the function, is the set of all values that the function g of x takes.
The domain of a function, g of x, is the set of all values for which the function is defined, and the range of the function is the set of all values that g takes. These are sometimes known as the input and output of the function. Now we're told that the graph of y equals g of x is a straight line, and we're given the domain of g of x, which runs from 2 to 8, and the range, which runs from 5 to 23. And so these two sketches for straight lines are examples that would produce possible expressions for g of x. In the first example, we see that the line passes through 2, 5 and 8, 23. So if I let g of x equal cx plus d, which is the equation of a straight line, and substitute, then I obtain the equations 5 equals c times 2 plus d, and 23 equals c times 8 plus d. Now I can solve these equations by subtracting one from the other. 18 equals 6c, which implies that c equals 3 and d equals -1. And this would give g of x equals 3x minus 1. So that's one possible expression for g of x. Here is another example I could use. In this case, the straight line passes through 2, 23 and 8, 5, producing the simultaneous equations 23 equals c times 2 plus d, and 5 equals c times 8 plus d. Now in a similar way, I can subtract one equation from the other. 18 equals minus 6c this time, therefore c equals -3 and d equals 29. And so another possible expression for g of x is g of x equals -3x plus 29. What is a linear inequality? Now, an inequality describes how one expression is greater than, less than, greater than or equal to, or less than or equal to another expression. A linear inequality in x, for example, only contains terms in x and number terms. There are no terms in higher powers of x, such as x squared or x cubed, and no terms in any other variables. Here are some examples of linear inequalities. 5x plus 3 is greater than or equal to 9. And x over 7 is strictly less than 2x plus 6. When solving linear inequalities, we can solve these in a similar way to solving linear equations, with one important difference. If at any point during the manipulation we divide or multiply by a negative number, then we must reverse the sign of the inequality. In this example, we're going to solve the linear inequality 3 minus 4x is greater than or equal to 10. So one way we can do this is by subtracting 3 from each side. Minus 4x is greater than or equal to 7. Therefore, x is less than or equal to 7 over minus 4. The reason we've reversed the sign of the inequality is because we've divided by a negative number. And of course we can also write this as x is less than or equal to minus 7 over 4. Alternatively, we could do the following. We start with the same linear inequality, 3 minus 4x is greater than or equal to 10. Therefore 3 minus 10 is greater than or equal to 4x, and so minus 7 is greater than or equal to 4x. And if we divide each side by 4, minus 7 over 4 is greater than or equal to x, which of course is the same solution as previously. The reason that we did not need to reverse the sign of the inequality here is because at no stage did we multiply or divide by a negative number. Solving linear inequalities. We can solve these in a similar way to linear equations, with one important difference. If at any point during the manipulation we divide or multiply by a negative number, then we must reverse the sign of the inequality. And when illustrating inequalities on a number line, less than or greater than, we use an empty circle because the endpoints are excluded. But if it's greater than or equal to or less than or equal to, we use a filled circle because the endpoints are included. You also need to know how to solve double inequalities. In example 2, we have to solve minus 5 is less than or equal to 8x minus 1, which is less than 7. And to start, we add 1 to each part of the inequality, so minus 4 is less than or equal to 8x, which is less than 8. And then if we divide through by 8 and simplify, minus 1/2 is less than or equal to x, which is less than 1. And we can see the solution illustrated on the number line. You also need to know how to solve simultaneous inequalities. Now the range, or ranges of numbers which satisfy both inequalities, can be seen more easily by illustrating the solutions to each inequality on a number line and then looking for the region, or regions, of overlap. Question 1, Part A. We need to solve the inequality 4 into x plus 1 is greater than x minus 2. So we can start by expanding the brackets on the left-hand side. 4x plus 4 is greater than x minus 2. Therefore 3x is greater than minus 6. And so x is greater than minus 6 over 3, which we can rewrite as x is greater than negative 2. In Part B, we need to solve the inequality 7 minus 2x is greater than or equal to minus 3. So if we start by subtracting 7 from each side, minus 2x is greater than or equal to minus 10. And if we divide each side by negative 2, remembering to reverse the sign of the inequality, x is less than or equal to minus 10 over minus 2. And of course a minus divided by a minus gives a positive number. So x is less than or equal to 5. Now in Part C, we need to represent the numbers which satisfy both of the inequalities on the number line. And we know that the solution to Part A was x is greater than negative 2. And this is illustrated with an empty circle at negative 2 and an arrow that points in the positive x direction. The other solution was x is less than or equal to 5, and this is represented by a filled circle at 5 and an arrow pointing towards the negative x direction. We're now interested in the region of overlap, because this produces solutions that satisfy both inequalities simultaneously. And this is represented by the blue section of number line, with an empty circle at negative 2 and a filled circle at 5. And the solution is minus 2 is less than x, which is less than or equal to 5. In question 2, Part A, we need to solve the inequality minus 3 is less than or equal to 2x plus 1, which is strictly less than 11. Now, sometimes the notation for inequalities can look slightly different. For example, here we have two slightly different representations for less than or equal to, but they have the same meaning. So here, we start by subtracting 1 from each part of the inequality. Minus 4 is less than or equal to 2x, which is less than 10. And dividing through by 2, minus 2 is less than or equal to x, which is less than 5. In Part B, we need to write down all the integers n which satisfy the inequality. Minus 3 is less than or equal to 2n plus 1, which is less than 11. Now the integers are the whole numbers, positive and negative, including 0. Now of course, if we refer to Part A, we already know that x is greater than or equal to minus 2 and x is less than 5 for the inequality in terms of x. And in part B, it's actually the same inequality, except x has been represented by n instead, and n is an integer. So we require the integers which are greater than or equal to -2, but strictly less than 5. Therefore, n is the set of integers -2, -1, 0, 1, 2, 3, and 4. In part C, we're asked to write down the inequality represented by this number line. The solid circle at -4 means we must include -4, and the empty circle at 2 means we must exclude 2. Therefore, the inequality is -4 is less than or equal to x, which is strictly less than 2. Lara's solution to the inequality 10x minus 5 is less than or equal to 6x minus 25 is shown on the number line. Is her solution correct? Explain your reasoning.
When the solution to an inequality is illustrated on a number line, it is important to know the difference between an empty circle and a filled circle.
Collecting the terms in x on one side of the inequality and numbers on the other, 10x minus 6x is less than or equal to 5 minus 25. Therefore, 4x is less than or equal to -20, and so x is less than or equal to -20 over 4, i.e. x is less than or equal to -5. The circle on Lara's number line should be solid since -5 forms part of the solution.
Question 28. Solve 7 open bracket x take 2 close bracket is greater than 63.
As a first step, you could divide each side of the inequality by 7. We can divide each side of the inequality by 7 as a first step, and since 7 is not negative, we do not need to reverse the sign of the inequality. Now 63 divided by 7 is 9, so we may write x minus 2 is greater than 9, and adding 2 to both sides, x is greater than 11.
X is greater than or equal to 6 and less than 11. Circle the inequality that shows this. Is it 6 is less than or equal to x, which is less than 11, 6 is less than x, which is less than or equal to 11, 6 is greater than or equal to x, which is greater than 11, or 6 is greater than x, which is greater than or equal to 11.
Note that x is strictly less than 11. The statement 6 is less than x is less than or equal to 11 means that x is strictly greater than 6, and of course less than or equal to 11. The next statement is meaningless because a number cannot be both greater than 11 and less than or equal to 6. Similarly, the next statement is also meaningless because a number cannot be both greater than or equal to 11 and less than 6. So 6 is less than or equal to x is less than 11 is the correct inequality.
Question 27. How are the whole number solutions to A and B different? A is when 4y is greater than 4 but less than or equal to 28. B, 4y is greater than or equal to 4 and less than 28.
As a first step, divide each inequality through by 4. Question 27. Consider the whole number solutions to A. 4 is less than 4y is less than or equal to 28. And if we divide through by 4, 1 is less than y is less than or equal to 7. So therefore y is equal to 2, 3, 4, 5, 6 or 7. Now consider the whole number solutions to b. If we divide through by 4, we get 1 is less than or equal to y is less than 7. So this time, y equals 1, 2, 3, 4, 5 or 6. So the solutions differ because in inequality A, 7 is a solution, but 1 is not. Whereas in inequality B, 1 is a solution, but 7 is not. 2, 3, 4, 5 and 6 are the other solutions, and these satisfy both inequalities.